As we've seen over the last couple of videos, there is a wide range in terms of complexity that a data structure might take. Maybe very simple with a primitive data structure where we just have a single integer, maybe very complex like we see with the standard template library vectors. So this spectrum that I'm going to be showing you in the next slide is not something that's out there. It's not a concept that you're going to see in a textbook, but it's just a way that I like to visualize data structures, because at the end of the day, we're going to have to start deciding which data structures to use. And sometimes it helps kind of having this mental picture of how complex a data structure may be compared to other ones. And so that's what I'm going to be introducing to you here in this video. All right, let's start off by giving us a line here that we could project our spectrum onto. And the first part of the spectrum is the leftmost, and we want to add primitives. So as we know, primitive data types are those non-divisible data types. The lowest level that we can store data as, and there's something like an integer, a boolean, double, maybe characters. Those are all examples of primitive data types. Then the next section of our spectrum would be all of our simple non-primitives. So things that are composites, things that are built up of integers and doubles and floating points, but they're not primitives. So in C++, they might be structures. Like we might have a structure that defines a point, and that point might store two integers within the structure, but we're not defining any behaviors on that particular structure. It's just simply storing data. And then arrays are very similar to that, where we're not defining how we can add or remove or manipulate the data within an array. An array is simply just storing data in a particular way. We move up a little higher on the spectrum, we get to our class array out of the standard library of C++. And that has everything an array has, but we have a few extra pieces of functionality and a little bit of extra information like knowing the size. So that's why I would say it's a little bit more to the right on this spectrum. And then if we keep going, maybe dynamic arrays would show up here. You can maybe argue that depending on how you implement the dynamic arrays, it might be further to the left on the spectrum. So if we're not storing the anything but the size of the array, and we're not having any other extra behaviors, maybe you can argue that it's less complex than a C++ built-in array. But again, most likely it's going to be a little bit more complex than an array, and so that's why I put it here on the spectrum. And then finally, we would have our complex non-primitives, and those would be things like your C++ vectors and other ADTs that you create. Now, this is a spectrum, meaning that these are ranges, and so it's not like there's a fixed location, but it does help to think of the data structures on this. So if I'm doing a simple program where all I know is I'm dealing with three integers, right? Maybe I'm bringing in three integers, I'm going to do some math, and I'm going to display the result of that math. I don't need a vector and all the overhead and all the extra bells and whistles that come with vectors to handle that. That's probably more appropriate to use a primitive like three integers, or maybe make it into a struct if maybe I'm going to do it multiple times, or an array of structs, right? So why add in that complexity if we don't need it? Now, on the other hand, if we need to be able to search and sort and maybe add and subtract and do all these different things to the data in terms of the number of data that we're going to have and the operations we want to perform, then it'd be very difficult to implement that program or develop algorithms for that problem using simple non-primitives or primitives, right? So we would want to go more to a complex data structure. So each of these data structures are going to have their place based on what we're trying to do. And the goal of this lecture series is for us to start to learn when should I pick various data structures and how should I use them. And that's the important skill that I want you as computer scientists to start developing in this lecture series.